Beautiful bastards, Phil DeFranco here. Just kidding. John here. I'm a software engineer with about 10 years of experience. Let's do some Leetcode. This is my first time knocking off the rust. You can see Leetcode submissions in front of us. I haven't submitted a Leetcode question in a year and 8 months. And you can see they all say JavaScript. Why was I doing merge case sorted lists like a bunch of times? I don't know. Maybe I was trying to see if I could get a better runtime. So it's been a while, and I am going to go all Python today. So what I'm hoping is that this is just like a warm-up, because I'm using the fact that I'm going in Python, which is kind of like a new language for my Leet coding. I program in Python all the time, but I don't traditionally Leet code in program. I don't traditionally Leet code in Python. So I'm taking that as an excuse. I'm taking the reason that it's been a while as an excuse to start back over with some easies. Probably kick it off with a 2-sum. And I'm hoping that it's just going to be really easy today. But we'll see. Maybe it won't, which would be hilarious. So let's just go to the problem sheet. Let's just go straight to 2-sum, right? And then, so what I would normally do is sort it by frequency. Oh, I don't have premium in. So usually if I'm like really prepping, which I'm not, I'm just messing around. But usually if I was really prepping, I would go premium. And I would ignore the Leetcode 75 because I have the 5 to 23 patterns article. And this is basically what I follow. And I'm coming out with a kata, K-A-T-A, a kata guide. And part of the reason that I'm doing some Leetcode is to figure out like what is the best kata guide. And that's going to be an improvement on top of this. But this is like basically the pattern that I follow, which is, I think, better than the blind 75. And you prioritize it based on the questions that companies ask. But for now, we'll just go to 2-sum, because I'm just picking, like, as far as I know, the easiest one. I don't know if there is an easier question than 2-sum. Let me know in the chat if you think there's a question that's easier than 2-sum, and then I'll give that a shot. Okay, so you can see it pulls me over to the JavaScript by default. Let's go Python 3, which apparently is different than Python. So whatever. Oh, I love that they have the, can I do this? I love that they have the type hints in there. Can I run this? Can I downcase the list? It didn't error. Dope. Hey, if you're on TikTok, you can go over to YouTube and see the full screen. So given an array of integers, you know what it is. It's the 2-sum. Given the array of integers and the target, return the indices of the two numbers so that they add up to the target. All right. Like, we'll start with some pseudocode. Naive solution is iterate through all nums n squared times. Better solution is I could sort or use a hash map. Like sorting would be n log n, so let's not. Going faux the hashy mappy. And that is actually what I would tell my interviewer. No, it's not. So I will call this just cached. We'll just call it cached. Maybe I could do like, should I do like a new dict or something? But I'm going to go with this cached approach. And that is going to be a set, isn't it? Yeah, that's a set. So here's a, nope. Yeah, that's a dictionary. That's a dictionary. For cur and nums, I could say cur int if I want to. If cur, like, let's do this. Cache, first of all, we'll cache it. So cached cur equals 1. I guess I could just use a set instead of a... So we'll do this with a dictionary, and then I'll come back and maybe use a set. So we're setting it equal to 1 to indicate that it's there. You know what? What I should set it to is the target minus. So cached cur. Let's just do this for now. Make it work and then make it work better. So we're going to put it in the cache and then no, I want diff, which is target minus cur. Because that's how I'm going to know if I have the target. So for cur and nums, diff equals target minus cur. If diff and cached, return the indices. Oh, okay, so I shouldn't set it equal to 1, I should set it to idx. So I want to do nums dot, what is it, freaking iterations. Now I'm showing how I'm weak on Python, great. Iter items, is it? Here I'm going to comment all this stuff and just log iter items. So we'll print cur. And I'm doing this just to see if I'm getting the iter item syntax correct. GitHub Copilot would have fixed this by now in my normal IDE work. Okay, list has no object, list has no attribute iter items. Maybe it's like this, iter nums. Okay, I think it's like that. Thanks for the likes. Cannot unpack non-iterable int object. Nums. So we got 2, 7, 11, 15. Then why did I iter at all? Yeah, why is this not giving me my my indices? Do you pay for the Copilot for GitHub? Yeah, definitely. It's not helping me out right now, is it? Okay, well I could just be a noob and just do this. But like, there's definitely a better way to do this. All right, let me know in the chat. Go ahead and cheat and let me know if you know the way that I don't have to do this. What is it? Is it iter items? Is this a thing? I feel like it's something like this, but I can't remember. Iter, oh, enumerates. We can do enumerates, right? Is that what I'm trying to remember? Your code is saved to local, upgrade to premium. Everything's on premium, isn't it? So cur value, I'm just trying to get the index built into the loop. I can hold it outside of the loop if need. Okay, there's the index. Great. So we have idx, cur value, and enumerate. And good. Now I have both of them. Okay, so I don't need to hold it manually like this. I mean, I could do that, but it's just not necessarily a good look if they're like, okay, this guy doesn't, whatever. I don't think it matters too much if you get the algorithm right. Cool, so now let's do diff. And then we want to, I'll print the cache each step. So cached, do I want to cache the target do I want to cache cur or the diff? So if I cache the diff, and then I run into the diff, I can immediately return true? No, I can't, because I need to know their indices. Okay, so I'm going to cache the cur value and set it equal to the index. Okay, cool. And so now, if the diff isn't cached, I can return the indices like I need to. Great, and I just failed my Leetcode interview because an easy took me like 10 minutes or something. How long has it been? I don't even know how long it's been. Yo, I'm so rusty, dude. But this is good. The juices are working. Okay, so here's diff. And if diff is encached, then I can return, does the index order matter? Indices are the two numbers. Doesn't look like the indices, well, they're going 0, 1, 1, 2, so they're kind of sort of descending. To do maybe sort, but I don't think it matters. Okay, cool. So we'll return the prior index, we'll just call it prior IDX. Prior IDX is cached diff. So is this right? Let's see. Local variable cur referenced before assignment. Oh, it's cur value now. Gotcha. Okay. Target is 6, output was 0, 0. Oh yeah, what's the base case? Like what if you never find the sum? You may assume that each input would have exactly one solution. Okay, so they're saying that there's always going to be a solution. Great. I'll just go ahead and do it, just like as written. We don't actually need this safe case. As written, but we'll add for completeness norms. What do I want to do? -1, -1? 0, 1, something like that? We can get rid of that to do. We don't want the set because we want to store the cool. So cached would be like so like I find 2, and that's the first element. So I'm storing 0. So 2 equals 0, but what I really want is the diff here. Maybe. Yeah, maybe that's the issue, is that I really want the diff here. Okay, so if the diff is here, value is IDX where prior key. where prior value was found. Cached diff. Oh no, this is not true. I could put it in an else. Okay, so now if diff is encached, how about that? No? -1, -1, so we're falling through. So let's go ahead and print the whole thing. Surprised that I'm falling through. So 7, 0, right? So we get some target value. Oh, here's the target. So 7, and then do I find a 7 later? So I do find a 7 later. So why does 7 not just return? So the diff is 7. And then next time that I come through, I have a value of 7. And the diff would be 2. That's the problem. So this should say if the cur value is encached. Why is it mad about that? Oh, there you go. Are you using an IDE? This is just what's built into Leetcode. Output limit exceeded. Whoa. Let me get rid of my print statement now. Cool. Could be a little bit faster, huh? Oh, look at the runtime here. My Python runtime is beating my old JavaScript runtime from years ago. Although, like, maybe that's like a version thing, so maybe the like new JavaScript would beat new Python as well. So, whoa, yikes. Do we want to move on to a new problem, or do we want to try and beat this? So this is like not efficient with memory. Look at that. It's better than average in terms of speed. Maybe I could speed it up some more. What would I do to speed this up some more? Oh yeah, I don't know. Will pulling it out instead of using enumerate, would that actually make it faster? I hope it does, because then I won't feel bad about forgetting the word enumerate in an interview. And they'll be like, why are you a noob and just holding your index outside like that? And I'll be like, because it's actually faster, believe it or not. Thanks for the follow. I don't know why I just hit run when I could have submitted it. Why did that happen, huh? Oh, because I should increment later. Gotcha. I can do this. It's so dumb. Let me get rid of that. I don't know. It's weird. It's like, I feel like the first thing I should do is write the base case, but that base case should never actually return. Maybe I'm going to return like that. That actually makes me feel better than the two negative ones. What languages do you know? Okay. So it was 1 millisecond faster. It was like negligibly faster. What languages do I know? JavaScript. Do you consider TypeScript a different language? So I don't know. Do you consider SQL? Like, what counts? JavaScript, TypeScript, Ruby, kind of. Python, I know pretty well. Java, kind of. PHP, like I used to do PHP every day, but it's been like, I don't know, 8 years at this point. So I can't really remember any of it at this point. And same with Visual Basic. So you throw me in a Visual Basic project, I'll pick it up in a couple weeks, but like, don't interview me with it. Probably those. Right, and then I'm not counting like HTML and CSS and stuff. You could count those if you want, whatever. Okay. Thanks for being here, Steph. So do we want to move on, or do I want to think about how could I improve the performance here even more? Maybe doing one of these. This is what I would do in JavaScript, right? Is like, you would do kind of like a while loop, basically. While IDX is less than length. Yeah, this feels stupid. This is just like when you're trying to get microsecond. These are micro optimizations, right? Curve value is not defined. Okay, and then this is like so dumb. Like honestly, even if this is a little bit faster, I would never do this I would never do this refactor in an interview. I got an off by 1 issue. How do I have an off by 1 issue, huh? While the index is less than the length of nums. It seems like really weird. Yeah, okay. My off by 1 in my brain was in the wrong direction. So is this any faster? Even if it is, I don't care. Okay, I'm not happy that it's faster, actually. Because it's like significantly faster, right? So the fact that it's significantly, what's up, Poppy Sensei? The fact that it's significantly faster means there's going to be like an interview somewhere where there's like some know-it-all interviewer who's like, did you know you could speed this up significantly by using a while loop instead of for in nums? I'd be like, fuck off, bro. Like, get a linter or something to take care of that. Why is my throat getting dry? I haven't even been talking that much. Okay, let's do another one. a different problem now. Let me know in the chat if you have a preference. Otherwise, I'm just going to go for like the next easy that I see, basically. This looks easy. Subscribe to unlock, right? Whatever. Go look for some easies. Oh, 2 sum 2 input array is sorted. So this, they say it's a medium, but like it's pretty easy. I guess it's like once you learn it, then it's easy, huh? Let's read it. Let's read it together. Given a one-indexed array of integers that is already sorted in non-decreasing order, so you might get like 1, 1, 1, 1, 1, right? You might just get a bunch of ones. Find 2 numbers such that they add up to a specific target. Let these numbers be index 1 and index 2. Where index 1 is less than index 2. Okay, so they do want you to return it in order this time. Fine, easy. There is a solution for each. You may not use the same element twice. Element here representing the index in the list, right? So I can use 1 twice, but I can't use the ith index twice. If I and I plus 1 have the same value, you get it. And if you don't get it, if you don't get it, put something in the chat and I'll clarify it further. Basically, when they say element here, they're referring to the index lookup on the array, not the primitive value or like memory reference or anything like that. Renegi, what up, what up? Appreciate the likes, thank you. Quick reminder, if you're on TikTok, you can go over to YouTube. Link is in my bio and see the full screen. All right, so there's not a base case. They do care about the sorting, and they're giving it to us sorted. So I just need pointers. I should be able to do this in O of n, right? And with I should be able to, what do we call this? This is like the target complexity. O of n time and constant memory. So this is like a no cache because it's already sorted. So if you remember like the last one that I solved, the whole reason that I created the cached map is because that would allow me to operate in O of n versus O of n log n, which I would have to do on the sort. So we favor the performance in that case. But in this case, the sort's already done. How do you say that name? That's a cool name. Dally? Dally? Dally says, easy, start at each end, walk towards each other until you get it. They nailed it. Yeah. It's a 2-pointer. We call it 2-pointers, right? Cool. Ooh, I wonder if you could do a binary search here. I wonder if you do faster than O of n. Whew. What would that be? That would be O of n over 2. So you cut it in half. It's not O of square root of n, is it? I don't think so. Like, maybe, probably not. I've never had a coding interview where I got a square root of n performance complexity. Oh, log n. Okay. Yeah. Is it? It would be, right? Because right, because in comp sci log means base 2. Okay, that would be. Yeah. Yeah. So my can we do it in this case is my question. I think you can, right? Like, why not? So maybe. Also, we call square root log. So don't be dumb. Thanks. All right, cool. I'm going to go for the O of n, and then, yeah, we'll do both. Why not? And then I guess that'll wrap it up for today. So we will try both because it's not a real interview. So I can be slow. This dude used to block everyone. Maybe. Okay. So, yeah, I mean, start, like I start equals 0. I end equals, whoa, some comments in the live were filtered to protect the community. What are y'all saying over there? I bet he's never built anything of substance. Wow, y'all are so mean. Hey, do you want to do a live challenge with me? Not really. Thanks, though. What did y'all say that it filtered? How do I look at that? I don't know. I can't, Yeah, I can't see what got filtered. Oh well, I'm kind of curious, but it doesn't matter too much. Dolly says, trying the quick solution and then discussing how to improve is a great interview tactic. Agree, 100%. Agree. All right, so we have the start, and then the end is just going to be the length. So let's say it's length 3, it'll be length minus 1. So length of numbers minus 1. And what we want to do is approach target, move right hand left to decrease, move left hand right to increase. Okay, and so I'll say while, we don't need to worry about the fail case, but fail case would be when indexes are, can they equal the same? Yeah, we can't use the same thing. When indexes are equal. But as written, we are guaranteed to not fail. So chill. Thanks. I love doing like Leetcode in my free time because I can say stupid stuff like that I would never be able to say in an interview. Let's say while I start is less than 2, just to make sure this is working. Cool. Just to make sure that this is working. 0, 1. Okay. Can it be negative? We should definitely check on that. Yeah, the target can be negative. Okay. So first of all, we need to check if the, okay. We're guaranteed not to fail, but if we were really being complete, we would want to check that the start is larger than the target. Fail cases would be when indexes are equal or start is greater than target, but as written, we are guaranteed not to fail, so chill, thanks. Yeah. So sum, like we'll call it cur sum, is here. We'll do get sum. We'll make a little helper. That feels not necessary. Yeah, okay, we would technically reuse it, so why not? We will not reuse it if I do my operation right inside at the very start of the while loop. So I'm going to start right here, as opposed to making a little helper that I call twice, which seems kind of dumb. So I'll just do the cur sum here, and that's going to equal the numbers plus the numbers. Okay, and this is, we'll do the end at the end and the start at the start. Okay, I start. And so here we will say shift equals 1 if cur sum is, so we want to move up if the current sum is smaller than the target, else -1. No, I don't like this. I want to do an if block instead of a ternary. So if the cur sum is, well, first of all, we should check if it's equal to the target, eh? If the current sum is the target, return foo, return to do, okay? And then elif, the cur sum is less than the target. This feels like a nice organization because, do the thing. This feels like a nice organization because you're going, oh, there's a name for this too, like equal left right. That's a search order. There's a name for that, but I can't remember. Let me know in the chat if you can remember the search or the search order. You are not calculating sum. What do you mean? Why don't I have patience for this coding? You know, because it's boring is the answer, right? You can use a dictionary. No, we shouldn't use a dictionary in this one. That would be unnecessary and that would bloat memory. So the input is already guaranteed to be sorted. Okay. Oh, can I just do I need to float it or can I just do INF without the float? Or even positive INF. Why does it need to be negative? And we just say while current sum is not equal to target. Okay. So if the current sum is the target, then I want to return the indices in order. So I want to return left then right. But I didn't name them left then right because I'd be silly. I mean, whatever. I think my names here are pretty good, but they're often called left and right. Okay. Otherwise, if the sum is too small, let's increase it. And so we will say I start plus equals 1, and else I end minus equals 1. Cool. Send it. The index is out of range. What is it, like an empty list? We're guaranteed to have 2. Okay, so let's walk through this case. So I come in, I have 0, and then I have length of numbers 1, 2, 3, 4, minus 1, 3, 0, 1, 2, 3. It's 15. So current sum is infinity. The current sum is not the target. This is true. It's not complaining about the INF, right? That's not the... Yeah, that's not the complaint. Okay, so we have 2 and 15. Oh, yeah. Okay, this is... Right, so it's 17. Okay, so let's keep going. If it's equal to the target, no, it's 17. Otherwise, is it less than the target? No, it's too big. So I end is minus 1, so we'll move left. No, we'll move left. And then we should get it, right? So what's the issue? Print I start. So I start is being increased incorrectly. Am I getting the... I'm getting the... I'm getting the wrong sum somehow. I'm getting the wrong sum. The sum. Zero, 17, 1, 18. How'd I get 18, dude? So it added 1 to the actual value somewhere? Did I? For real? Current sum. Let's look at the test case. Source mode. You can now edit all your test cases in one editor. That's kind of cool. All right, cool. That's cool. So 2 and 7. So how did I get to 18, dude? Because I have 0 and 15. Okay, because of this freaking this thing at the end. That shouldn't be there. That's the issue. Great. Okay. Okay, 0, 17, 0, 13, 0, 1, expected 1, 2. Why did you expect 1, 2? Those don't add to the target. 0, 1 does add to the target. Is Python better? No, Python's not necessarily better. I've been doing Java for a grad class, and it used to be rough, but I think it's getting better. Yeah, you just code with whatever you're good with. I used JavaScript for years. Actually, that's kind of the point of the stream, is that I'm using Python. This is like the first time that I'm leet coding with Python. I've been coding for 10 years, including years of Python, but I never used it for my interviews. Because I was always like 10x better with JavaScript, but I don't think that's true anymore. I think I'm still a little better with JavaScript, but I think it's like a 10-20% difference kind of thing at this point. And I do think if you're roughly good with different languages, including Python, Python is super nice for interviewing because it has a bunch of built-in data structures like an ordered dictionary that I would have to create that by hand in JavaScript, which is pretty painful. How do you feel about being a software engineer for a corporate bank? That's fine. I mean, it kind of depends on which bank, right? Like Capital One is somewhat tech forward, and then other banks are going to be like just like really old code, but they still, well, and then some pay well and some don't. So it depends. I wouldn't make a whole group out of it. Have you heard of M&T? Yeah, I heard it's mid. What do you think? Do you work there? I'm not trying to put you on the spot. Sorry about that. I heard it's mid, though, in terms of the technology. All right, so why... Oh, it's given a 1 indexed array of integers. That's why. Hello. Hello, hello, hello. Cool. Attention to detail, eh? Ta-da! Trying my best to get my first internship there. Wait, what's the website? Yeah, this is Leetcode. What's up? Thanks for being here. Okay, so it worked, but it looks like really slow. It's not really slow. It's around the average. Beats 46% of users with Python free. The memory is bad. Why is this? Maybe because I don't need to carry cursum. I actually don't need to carry cursum at all. See, this is... you do, though. You do need to carry it, right? Unless I want to duplicate the code, which I don't. I mean, again, this could be hacks that like... This could be like hacks that make your Leetcode do better, but it's not good code. All right, let's see what that does. Cursum is not defined. Fine. Wrong answer. What, dude? What? Whoa, okay, this is fun. How did that happen? So this works. Okay. It's not like it's not like missing parens or something, is it? I didn't output anything? Because it ended up equaling the target, so then I should indent over here. Boop. Is that the issue? Yeah, that's the issue. Okay. What time is it? It's like 10:15. Okay, now all of a sudden we're fast. Now all of a sudden we're awesome because I duplicated code and I didn't use Cursor basically. Bhushan, what up, what up? Hello from LinkedIn. Thanks for being here. Quick reminder, if you're on TikTok, you can go to YouTube or LinkedIn. Links are in my bio. I actually don't know if my link isn't in my bio, but my YouTube is, so you can go there and see the full screen. So this solution stinks. Like, I don't care that it's 2 milliseconds faster and 0.2 megabytes less memory, and it went from red to green. In terms of how many people I beat, it went from 5% under the average to 10% above the average. Like, I don't care, dude. This is not good code. This is not good code. And I feel like juniors have trouble saying that sometimes. Is if you're like a junior, you might think, well, like, is this better? Like, it's less memory. It's a little faster. Is this the better way to do it? No, this is an awful way to do it. The way to do it is carry the cursor on. Boop. So I'm just going to copy it. If you run it again, it will be red. That's how Leetcode works for some reason. Yeah, there's the random variation, right? Below is, I'll call it the uCry implementation. You can repeat yourself. For reference, slightly less mem, better perf, and it's awful. Use cursor for maintainability. Okay, great. So we just keep this just sort of like for reference. Actually, in theory, I don't need the block. So that's kind of nice, right? I get to eliminate one condition. That is nice. Boop. Let me comment this. Now that I've slightly changed it, is it going to be even better? Maybe I'll get 0.01% more better memory usage. Wouldn't that be great? And now that one was slow. So don't use that extra one computation. That will apparently cost you 20% in the Leetcode leaderboards. Wouldn't that be awful? You don't want to be in the bottom 50%, do you? Here, let's run it again. I'm so curious about this. Now it's even worse. It's got to just be random variation, eh? Yeah, it's just got to be random variation. Because that shouldn't actually run an extra calculation. Cool. So since you're repeating it once, it's actually not that ugly, and you eliminate the condition. That's like kind of cool. That's kind of cool. I'm not actually that mad at this. But if I had to repeat the expression 3 times, I'd be like, oh. So we'll comment that for reference. Keep it for reference. And then here, below is naive O of n implementation for reference. But we can be faster with binary search. Okay, now let's use the... By the way, I shouldn't start with infinity. I should start with the sum. So I end up, see, I end up repeating once in either case. This is something, okay, this will save me like one cycle if I do it at the end instead of a start. It doesn't really save me a cycle because I pulled it out here, but I don't have to do that INF thing, and I get this nice return statement instead of an additional condition inside of the code. So I think this is actually better. Let's come over here and use this. I think that works, right? Oh, my, yeah. My block is broken. Cool, hey, that was, I don't know if it was random variation or not, but that was actually a nifty chunk faster. That's the fastest one yet. Although the memory was worse. Great job so far. Thanks, Abdul. Okay, so this is the naive implementation. You're in the interview, right? They give you this easy. You're a junior. It's your first time out of your basement. I don't know. It's like, and you say, yeah, here's your O of n, and they say, well, can you make it faster? And you bust out that binary search. You ready? You ready to bust out some binary search? You take a sip of Fiji water because your parents are rich. Your parents are rich, and that's why you got to go to MIT and drink Fiji water. Okay. So yeah, I'm going to do binary search down at the bottom because I don't like doing the binary search at the top. It makes it look like, oh, I just like whipped out binary search. What I really did is I wrote it like this, and then I improved it. So let's go down here. Boop. Okay. I still want the cursum. And I'm still going to say while cursum is not equal to target. Okay. I'm going to just like duplicate this code because I don't want to like be scrolling up and down and stuff. So boop, we'll do, oh, you know what? Yeah, that works, whatever. We're still going to do this. We're still going to do this. The difference is what happens here. Divide into. Yeah. So midpoint is I start plus I end over 2. Okay? And so if needs to increase, and then else needs to decrease. And so here we'll say I start equals midpoint. And here we'll say I end equals midpoint. Needs to increase is going to be like this: cur sum is less than the target. How about that? List indices must be integers or slices, not float. Okay, right. So do we want to floor it or roof it? I usually prefer to floor things because roofies are bad. Wow, did I really get a like from that joke? Y'all are great. I love you. Only this audience would like that joke. Okay. So how do we floor it? This is where like the Python versus JavaScript and the words are hard. It's math.floor and JavaScript. Is it just floor? Is it just floor? Is it round? Okay, round. Does round down by default? Like, I don't know. I don't get any IntelliSense or anything. That's so brutal, man. Wow, I really want to Google. Integer division, use 2 slashes. Oh, there you go. There's a pro tip. And so will it floor it, Caleb? Will it end up rounding it down? Or will it round it like bank rounding or whatever? Oh, okay. There you go. W chat over here. It should round down. Dope. So I might need to still handle an off by 1 sometimes. Time limit exceeded. Ooh. So it never converges. It never converges. So yeah, maybe I should do +1. Yeah, here if we want to move the left hand, we'll be conservative on the left hand, so we'll do midpoint -1. And here we'll do midpoint +1. So what would the effect of this be? Would I still reach a case where I never converge? Yeah, the case would be if you're 1 apart. That's okay, because we don't want those hands to touch anyway. Here, let's see. Whoa. Scheifer, have you made a GPT yet? I have not done it. New feature is fire. Cool, cool. Yeah, I have not done it. I should. So the integer division will round down. They finna replace us. Not really, dude. What's the question? This is just 2-sum. This is the variation where they give you sorted input. Okay, I guess we can print. I think probably we just want to handle, they are the same number. So I start equals midpoint. And then, yeah, we can handle it over there. So I did this conservative thing, but there's actually only like, you only want to do that conditionally, I think. So if midpoint is I end, else. Another way you could do this, you could say, yeah, I start is the midpoint, and if I start is now I end, then I start minus equals 1, and you get rid of that else. I start and I end flipped, they say. Oh man, now I feel bad reading the chat. I feel like I cheated. If the cur-sum is too low, then no, you're moving the start to the midpoint. So you're moving the start right. So I don't think they're flipped. I don't think it's a directional problem. Now I don't feel bad about reading the chat. I only feel bad if the chat's right. So now we set the end, and if I start equals I end, now I end. Oh, okay. Did you mean this part was, let's see. Yeah, I don't think they're flipped, but maybe the, hold on, let me go back. Was the modifier flipped? So it's a +1. No, I was doing +1. Expected a semicolon. Yep, I did too. I did too, believe it or not. We both expected the semicolon. Where'd it go? Who knows? I'm not printing, am I? Okay, well, I should stop that. Output exceeded. Yep, sorry about that. Whoa, how is that not fast, bro? How are we stuck? We're getting some non-convergent condition. The non-convergent condition is when I jump too far. That's the problem. Okay. So if the current sum, the target is greater, and I jump over here, boom, now I'm too big, and I'm moving the right down. But maybe I need to get that left hand over here. Interesting, interesting, interesting. Yeah, basically my binary search algorithm is wrong. How do you know what data structure to use? Okay, that's a good question. Well, I went through that earlier in this video. We're only using pointers here. And the reason that we can do that is because the input is already sorted. So I don't need a caching mechanism at all. I only need pointers. So I think that's pretty much, in terms of data structures, that's pretty much the first question is like, can you get away with pointers? Like use pointers and primitives if you can, and then if you need something more complicated, go for it. And then you have that question about what sort is the complicated structure? Is it a hash map, a stack, a queue? Like what is it? But I don't need a caching structure at all, so that's why I can do primitives and pointers. Does that answer the question? Okay, so this binary search is wrong. So why is it wrong? The reason it's wrong is because I am jumping too eagerly. I'm jumping too eagerly with the pointers. Okay, so how do I fix this? Here, when I set the midpoint, that's basically like that's not what I should do. I need to look at the next move as well. I need to look at the next move as well. Okay, so this binary search, I might need... four or five pointers. I might need 4 or 5 pointers to get away with this. Okay. So we have I start and I end. And now we don't want to set I start here. We want to set next. Next right and next left. We want to set these bad boys. So what is the what are these default values? So the default for the midpoint is this thing. And then the default for next right is midpoint, and the default for next left is midpoint. Okay. So next right is midpoint. I can do these inside the loop. Why not? Do I need to calculate them every time? I do, so why not? Okay. So we have the next right and the next left. Now, if the current sum is less than the target, I want to increase left pointer. And so let's do the left first. It's alphabetical, and it's also the first case we handle. So here, the next left will be the midpoint, and the next sum is going to be by the way, I also need to add the one-off modifier in case we end up pointing to I end. And then down here at the end, basically, we will say that the start is the next left and the end is the next right. Is the midpoint the root node? No, the midpoint is literally the integer average of the two indexes. So if you think of like an array, I'm starting with pointers on the outside and I'm working my way in. And the midpoint is literally the average index between my left and my right. Between my I start and my I end. So that's why it's a binary search. Instead of moving a little at a time, I'm like jumping over a bunch of indices. But in my naive binary search, I was jumping too aggressively. I need to jump and then check, and basically like there I'll be able to turn when I jump, I'll be able to determine like hot or cold. Like, do I want this window or that window? I'll be able to pick my right window. Does that make sense? I really like Leetcoding while streaming because it forces me to speak better. Okay, that makes sense. Thanks. I'm glad you're confirming that makes sense. Because if I end up doing this in an interview, bro, I would be bumbling, dude. I would be like trying to explain like binary search. Like, it's a simple concept, but I haven't, I don't need to explain it. Like, when's the last time I explained binary search? So, good. It's good to do this. Thanks for being here, by the way. Okay, so so we have we want to increase the left pointer, so we're setting next to the midpoint, and then we are backing off one index so that we don't have two pointers at the same index. Hi.
You want to watch Christmas with me?
Sure. When I'm done streaming, it's going to be like probably 10 minutes. Can you get food for the dogs?
Yeah.
Thank you.
Do you want to see a cool thing I did? And it was terrifying and I almost died.
In 10 minutes. Okay, so now I have my next left, and then I'll figure out my next sum. And my next sum is going to be next left plus next right. Okay, so these should start out to be I should start those out like this, actually. Yo, my throat is getting dry, dude. And so if next sum is equal to the target, return, else else if next sum is less than the target, else. Okay, cool. We basically have to look one step ahead. So if that's the case, then we want to return the indices, right? And this is going to be the same story on the other side of the block, on the over here. So here we're doing, yeah, okay. I'll just copy the whole thing. I mean, the good thing is, like, the algorithms are still, it's like riding a bike. The algorithms are still there in my brain, but you can see I'm being very slow. So we've been here an hour and a half. We're going to be doing basically 2 easies in an hour and a half. Granted, I think I did 2 forms of each of the, I did 2 forms of this. I can't remember if I did 2 forms of the other one. So I did 3 or 4 solutions in an hour and a half, but still, like, this should be, these 2 I should be able to do in half an hour, so. we're clocking in at like 30%, 30% of the goal, but that's okay. It's actually not too bad, all things considered. Okay, so next right will be the midpoint. And if next right is I start, then next right will be conservatively bumped 1 to the right. Then the next sum is like that, and then if the next sum is the target, we'll go ahead and return. Otherwise, if the next sum is left of target, to do and let's go back to do, and then we'll be done. All right, so for this one, are they all going to be similar? So if the next sum is left of target, yeah, they're all going to be similar, right? Okay, that's wonderful. We'll get to abstract this block. That's going to be wonderful. So if the next sum is left of target, then my next left should be my I start. And my next right should be my, okay, let's do this in the reverse order. So my next right should be whatever I thought this was going to be. So my next right should actually be I'm basically picking the other window. As next step. Pick the left window as next step. Pick the right window as next step. This is the idea of what I'm doing. So they're not actually going to be, yeah, they're still going to be, I think they're still going to end up being identical. So my next right is going to be whatever I thought the next left was, and then my next left will be my I start. Okay? In the other case, my next right is going to be I end, like the very far to the right, and my next left will be the midpoint. Hold on. That's right, and then we need to offset and then we need to adjust the midpoint. Did we not already adjust the midpoint? Next left is midpoint. If the next left is let's see, do I need to adjust the midpoint? Is it possible that yeah, I just created this problem for myself. I totally just created that problem for myself. I'm sorry about that. So what I should do is I should say my next left is whatever I thought the next right was going to be, which should already be adjusted on the midpoint. Nope, I'm not sure about that. So my next right is already I end. My next right is already I end. Okay. So I do want the midpoint. I'll do the adjustment here. Yeah, let's do the adjustment here. If next right equals next left, then next left minus equals 1. Which is like, I could probably abstract that a little bit if I think about it more. But whatever. Okay, so I think I can just take this whole block and use it over here. Let's see. Body yaddy yaddy. Sup, King? How's it going? Okay, so that worked. Let's submit it. Da 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 da. It's gonna time out, eh? Bummer. So here's the case where it times out. We want to get to 200. So the solution is going to be, what, 50 and 150, huh? So I start with 345, and the sum is larger than the target. So I want to move my right hand left. So in the naive, or like in the non-binary, right? Like in the linear search, I would move that to 150. But since I'm doing this binary search, I'm going to move it halfway in. So 1, 2, 3, 4, 5, 6, 7. Okay. 1, 2, 3, 4, 5, 6, 7. So that will average on the 0 index, 0 plus 7, 3.5. And then it's an integer division. So I think it's going 0, 3. 0, 0, 1, 2, 3. And this is the left window, and this jump is too aggressive. And so the way that we tried to address this is by doing a look ahead one step and saying, oh, I know that's going to be the wrong window. Let me pick this other window. And it seems like I did that incorrectly. So maybe the issue is that I'm pointing, so this would be 0, 1, 2, 3. So 3 would be next right. So we're in the case where the current sum is greater than the target, so we want to decrease the right pointer. So the next right is I start. Oh, not at all, dude. So the next right is this midpoint. Okay. And then if it's equal to the next, then we'll be one more conservative. But that's not the case. So far we're right here. We get this look ahead, and it says like 82. And is that the target? No. Is it less than the target? Yes. And so I go, oh shit, I need to pick this other window. So how do I do it? So now my next right, pick the left window. The next sum is less. If the next sum is less than the target, okay, so I got the wrong, I switched my windows basically. If the next sum is less than the target, pick the right window as next step. Is what I should do. Okay, so then I'm over here, and what I do is my next left should be whatever my next right was going to be. Okay. My next left now becomes the 79 pointer. Arguably, maybe it should be 88. Let's leave that alone. Let's leave that alone. So we're going to go for the 79 pointer and then flip the 3 pointer back to the I end. So next right becomes I end. Okay. I think I just flipped those two. Okay, so in this case, the next sum is greater than the target. Oh no, it's too big, so we want to pick the other window. So pick the left window as next step. So here, oh no, we want to pick the other window. So my next left should become I start. And my next right should become the midpoint. My next right should become the midpoint. But we need to do this thing where it's like, yeah, but if the next right is going to be the next left, then we need to be conservative. And what does it mean to be conservative? In this case, we draw a bigger window. And so then it would be next right moves one more to the right, plus equals 1. And then we lock those in. Bam. Which Leetcode is this? This is just two-sum, but I'm going for the binary solution. So this is 167 two-sum 2. It's the variation of two-sum where the array is already sorted. Whoa, bro, what just happened? Hold on, stop, go back. Take me to the panel. Okay, time limit was exceeded. Okay, so apparently I am not getting this binary solution right. So let's go look at the other people's solutions. Oh, 1. Oh, it's O1 space. Yeah. I did O1 space, right? While IJ, this is the linear setup. Yeah, good. Yeah, so I already did this one, but there's a binary solution. Nine lines, logical binary search. Here we go. Let me go back and give the other guy an upvote. Like, good for them. Where's the upvote thing? Did that vote even work? What the? Please up. Yeah, dude, let me upvote, man. I don't know. Bottom left. Oh, okay, cool. It's like floating there. Thank you. Thanks, chat. Okay, so where's this concise binary one? Binary search, whatever. All right, so here we have left, right is 0, and yeah, so you set the boundary, right? And then while left is less than right. I guess that's fine. Okay. Yeah, that's a fine condition. Oh, and let's give this person a vote as well. So while left is less than right, what is this? Cur sum. Okay, so this is the current sum. Is you get the sum. If the sum is greater than the target, r minus equals 1. That's not a binary search, dude. Yeah. No. Not a binary search, amigo. Bummer, dude. Somebody's gonna have a binary search over here. Okay, so here's the midpoint. With cute approach, what does that mean? It's n log n. No, it's already sorted. Should just be log n. And enumerate numbers. Why do they do that? What? While left is less than or equal to right, it should never equal right. While left is less than right, here's the midpoint. Okay. Good. N is number. Oh, this will be like next. So next is numbers I. Oh, okay. Okay. This is somewhat interesting. So if it's the target, we return it, right? Otherwise, if it's less than the target, the left becomes mid plus 1. Okay, so I was being conservative by saying the left becomes mid minus 1, right? Next left is midpoint minus 1. So I wonder why you add 1 and that fixes the issue somehow. Interesting. Oh, so they're doing for I and range to compensate for the aggressive jumping. So, okay, that's why they're getting away with aggressively jumping. No, that's not a good solution. No. This is a slow binary search. Okay. So I don't want that is n log n. They measured it correctly, but it's not actually. It's not an ideal binary search. It's like a slow binary search. Let's see if I can find one more. Yo, people just call anything a binary search. What's going on? Okay. So no one is finding like a fast binary search with just log n. They're all doing this n log n thing. I need to like figure out why this is like necessary. So the right is, this is like an aggressive jump, right? They're cutting the window further. And they're just like leaving out random vowels. Like, let's take the letter I out. We'll keep the letter I over here, but in the word right, we're taking it out. Efficiency. All right, this one is for James. Like, why do we do that? All right. I think that's going to wrap it up for today. And I need to think about why this solution doesn't work. Oh, let's ask ChatGPT. I want to write an efficient Python binary search to solve two-sum. Leetcode algorithm question. In this variation, the input is already sorted and is guaranteed to contain a valid answer. Here is one proposed solution. I notice this is O of n log n, which is a slow binary search. I would like to achieve an O of log n solution. Is the outer expression necessary? Okay, it says this is the most efficient approach. I just want to ask it why this fails to converge. Thanks for the follow. In a standard binary search, you typically check the value at the midpoint against your target and then adjust the search space accordingly. In your case, you're trying to adjust the search space based on the sum. This method does not reliably move towards the target sum. No. That's not true. Okay, so I think I could do a hybrid search that uses binary or linear search. What do you at each iteration? Would this have a convergence guarantee? So the problem is that wouldn't improve my worst case performance, but it would definitely improve my average case performance. All right, well, I'm not going to do the hybrid search today, but basically like, yeah, why would I not jump? I feel like I can do the bifurcation until we get into like a finite range of like maybe like 3 or 4 elements, and then linearly scan over those. Here, maybe I can do this quickly. If let me literally just grab the Oh, how did my left? How did they get flipped like that? I start, I end. Did I get these backwards? Okay, I need to think about this some more. I think we're on to something, folks. Dun, dun, dun. I don't think this is going to work. Just sort of like naively doing this. What? Yeah. 6336. Let me undo that. Okay, I think we're on to something, but I need to investigate why a larger number came first. I really don't expect that. I start is next left. I think this be sus. I think this might be sus. We're still getting 6-3. All right, I'll take a look at it. Thanks for tuning in.